In this recording, we're going to be talking about congruent triangles. So if we start off with a triangle, this is a scalene triangle because none of the sides are the same length. The side AC is the longest, the next longest would be BC, and the shortest would be AB. We say that if I have triangles that are congruent, the length of segment AB, and copy it perfectly so that its length is exactly the same, and call that DE, and take the length of BC, the same size, and connect it to EF, and then finally take a length AC and put it where DF is, then we end up with congruent triangles. Now, the reason why these are congruent triangles is because the definition of congruent triangles says that if I say that triangle ABC is congruent to DEF, I'm literally saying 6 specific things. I'm saying segment AB is congruent to segment DE. I'm also saying segment BC is congruent to segment EF. And I'm also saying that segment AC is congruent to segment DF. So there I have the segments talked about. There's AB and DE are congruent to each other. BC and EF are congruent to each other. And AC and DF are congruent to each other. So that's saying that the 3 sides are congruent to each other. Similarly, when we talk about congruent triangles, we are also saying that angle A is going to be congruent to angle D. And we write it this way. Angle A is congruent to angle D. Angle B is congruent to angle E, which means that they measure the same as well. And then finally, we can say angle C is congruent to angle F. This is specifically what we are saying when we say we have congruent triangles, that we have 6 parts that are congruent to 6 parts. 3 of the parts are side lengths, and 3 of the parts are angle measures. Congruent means measures the same. And so if I was to say that AB was 5 centimeters, then DE must be also 5 centimeters. Let's take a little time to talk about how we actually say the measurements and combine them with numbers. So as we talk about numbers, I'm going to say that AB was equal to 5, and I'm talking about the length of AB. Notice I'm using the symbol equals and not congruent, because congruent means that I'm talking about 2 geometric figures that measure the same. So AB is a line segment, DE is a line segment, and they measure the same, and so they are congruent. Similarly, I can say that BC is equal to EF, and that's actually saying the measure of BC is equal to EF. Notice I don't have bars on top when I'm talking about the actual number measures of things. And similarly, I can also say that AC is equal to DF. That's how we say it then. And now, what if we were saying that the measure of angle C was equal to 33 degrees? Then I can also say that that means that the measure of angle F is equal to 33 degrees. So what I'm saying when I say that triangles are congruent, and in this case, triangle ABC is congruent to triangle DEF, we are saying that 6 parts are congruent to 6 parts. Now, even in the writing of triangle ABC is congruent to triangle DEF, I want you to see that AB is the letters of the first segment, and DE are the letters of the first segment of the other triangle. And similarly, if I look at BC and note that BC are the letters of another segment, and that the letters EF are another segment. Notice how that corresponds with what we're talking about here, that I'm talking about triangles that are congruent. Literally, you can say segment AB is congruent to segment DE, and segment BC is congruent to segment EF. And as well, you can say AC is congruent to DF. And so just in the writing of congruent triangles, you can actually pick out the pieces that are congruent to each other. And likewise, this works with the angles as well. Angle A is the first angle mentioned, and angle D is the first angle mentioned in the other triangle. So angle A is congruent to angle D. Angle B is going to be congruent to angle E, and angle C is congruent to angle F. So all in all, we're talking about the definition of congruent triangles. And in this case, triangle ABC is congruent to triangle DEF.